Hi friends, welcome to Arnav's world. Today is the 10th episode in the science series. So in science, it is physics. So in physics, we are going to discuss about nuclear energy. Yes, more energies. So nuclear power is the use of nuclear reactions. Yes, reactions. These reactions happen in nuclear power plants. So these reactions produce electricity, which is very important for our society. Yeah. So nuclear power can be obtained from nuclear fission, nuclear decay, and nuclear fusion reactions. Yes, three types of reactions. So presently the vast majority of electricity from nuclear power is produced by nuclear fission of uranium and plutonium in nuclear power plants. In the world, it's the 11% of the whole electricity is nuclear energy. Yes, nuclear. So the generating electricity from fusion power remains the focus of the international research. Yes, people are still researching about this fusion and nuclear fusion. So, nuclear reactions are a highly efficient way of releasing energy. Yes, in nuclear reactions, the atoms will fuse or just mix together or separate. Other smaller particles in the atom will go away. Yes, these are classified in different ways. So, nuclear reactions are highly effective. Yeah. So most elements have several slightly different forms called isotopes. In isotopes, there are less or more neutrons. So one example here is the normal hydrogen atom. So it has one proton. It's a normal stable hydrogen atom. But there are two isotopes for this hydrogen atom. So the two are tritium and deuterium. Deuterium has one neutron and one proton, while tritium has two neutrons and one proton. Did you think there were going to be two protons and one neutron? No. Yeah. So, okay. Each isotope of an element has a different number of neutrons. Low or less. More or less, yeah. Okay. Each isotope has, So, isotopes of heavy elements such as uranium and plutonium may break apart or decay. Yes, here decay means the neutrons will go away to make the atom more stable. Yeah, that is radiation, nuclear energy. Yeah. This will produce radiation, remember. So atomic nuclei can also be broken apart, which is fission. So when they are broken apart, it is called fission. It is the one which happens on Earth, man-madely. Or if the atoms are just joined together, it is called fusion. Yes, this fusion only happens from the sun or stars. We can't still make it on Earth artificially. So these are the types of ones which can be made artificially. But up to now it's only the fission which is made artificially. The fusion needs a lot more heat and a lot of pressure. Yes. So these can be used to release energy which can be harnessed in nuclear power stations and nuclear power weapons. Yeah, nuclear weapons like atom bombs. Those are very dangerous. They produce a lot of energy and nuclear energy. Yeah, so the types of radiation. So there are three main types of radiation. So when unstable nuclei break apart, they will break apart if they are unstable. So also they will decay. Yes, decay means neutrons will go away. Bye. So they may release three types of radiations. They are alpha, beta and gamma. Yeah. So alpha and beta radiation are streams or particles released by atomic nuclei. while gamma rays, which are different from these two ones, are forms of electromagnetic radiation. Yes, that means it is similar to light and is similar to visible light. That means it is a type of light which we can't see. Yeah. So, but more powerful and dangerous. Yes, a lot more dangerous. So, I'll show a diagram of it. So, right. Okay, I have some fireplace. So there are three types, right? So this one is alpha. It is like a small nucleus made up of 2 protons and 2 neutrons. Yeah, plus and plus. Yeah, so this is alpha. So this is a bit big than other ones. That means it can only pass, it can't pass through skin. Yes, so yeah. Next, the small betas. This is beta. These are 1 neutron. Yes, only 1 neutron. So it can pass through skin, but it will not go through aluminium. This is aluminium. And if you don't know, this is skin. And the last one, which is the gamma radiation, is just like a ray. So no dots or particles. So this one, this is the lead. So these gamma rays can go through the skin, aluminium, but can't go through lead. Yes, the lead metal, not the lead which is on pencils. Yeah, it is made of carbon, not the lead metal. Yeah. Nuclear fission, one of the ways to produce the nuclear energy. So this nuclear fission is, in this, the nuclei of atoms can split apart or join together. So they form new elements and release energy, nuclear energy to be exact. So a large atomic nucleus splitting in two is called nuclear fission. Yes, this is nuclear fission. This is possible on Earth. Yeah, so that means this can be made artificially. Yeah, so a neutron hits the nucleus of a uranium atom. So here this is happening, causing it to split or fission into two. Yes, the stylish way to say split is fission into two. Yeah, so here in these 3 diagrams it will happen. So more neutrons are released as a result, and these hit more nuclei, creating a chain reaction. So these are called chain reaction. Yeah, it is a process that goes around and it's a cycle. Yeah, it's a cycle. So the extra energy that is released ends up as heat. Yeah, heat that can be used to generate electricity. Yes. So here now I'll explain the diagram of the nuclear fission. So here a single neutron hits the nucleus. See the small green dot, the round. So this is a uranium nucleus, very big. Not the whole atom, only the nucleus. Yeah. So this nucleus will hit the uranium nucleus to make it into two. So the neutron causes the uranium nucleus to split into two. So here this explosion will cause heat energy. Yeah. So then some more of these neutrons will go away and hit other uranium nucleuses or nuclei. So more neutrons are released, which carry on the chain reaction. Yes, these chain reactions can happen for 3 years. The minimum is only 3 years. That means it can last for so long. Yeah. So next, another type of producing nuclear energy, nuclear fusion. They will mix. So in this process, so in which two similar atomic nuclei join together. So this is called fusion, nuclear fusion. So two isotopes of hydrogen are smashed into each other to make helium, releasing the heat energy in a spin neutron. Normally, scientists use only the two isotopes of hydrogen, but other molecules we can do it with other atoms, yeah. But because these isotopes of hydrogen are more easy to get, that's why we use these isotopes. So fusion takes place in stars. Yes, that's why we get the heat from our own sun. Yeah, that's why we still here. The sun creates heat. Yeah, so on Earth we need immense heat and pressure needed to start this process. We need lots of heat and pressure because normally these atoms, these small nucleuses will not get close together to make them just fix together to make a new nucleus. So now I'll explain the diagram of the nuclear fusion. So first there are two isotopes of hydrogen, deuterium and tritium. In the top is deuterium and in the bottom is tritium. So suddenly they'll just mix. So they'll cause a small nucleus with 3 neutrons and 2 protons. So now a heat energy will come, heat blast. So then one neutron will go away. So an extra neutron is just released out to the place. So now a helium nucleus is produced. Yeah, this is what happens in the sun always. Yeah, that's why we get all the warmth. And yeah, this is about nuclear energy. And wait, this is not the end. This is still the first part of nuclear energy. There's still more about this. Oh, there will be a second part in the next 2 weeks later. So bye.